So I came to the conclusion that I wanted to talk about Catalyst for the Zoho developer, because Catalyst is this massively broad platform where a lot of things can happen. And a lot of the webinars I've attended in the past on Catalyst, it often focuses on this use case or that use case, all of them great. But what I hadn't found yet was a way for someone who is used to primarily doing Zoho development to step into Catalyst and feel comfortable learning more. And that's something we've been working on in our own team. In fact, Catherine here on the call with us is on our team here at Aspen 94. And so like she and I have been working on some of this together, and it's been an internal effort. And I wanted to share some of these things with the broader community in terms of how, as someone who's primarily used to Zoho development, you can step into Catalyst, get your bearings, and start to do some work. So let's talk about why, as a Zoho developer, you would branch into Zoho Catalyst. I use Deluge all the time. I know you all use Deluge all the time. Most of the time we love it. Now and then we get very angry at it, right? And it's because of the nature of what Deluge is and what it's intended to do, right? It's a scripting language that's designed to enhance, primarily to enhance the kind of interactions and automations that can happen inside of a Zoho application. Sure, we use it to work with external APIs. Yes, absolutely. Maybe we use it to do I don't know, math or other kinds of algorithmic computational things, but it's intended to be essentially a code execution environment that comes with your Zoho license that allows you to do pretty amazing things. But Zoho has to put limits on it for that reason, right? Because you could, in the absence of limits, you could really abuse it. And so I have found that Catalyst is an excellent place to go when I have automation requirements that cannot be accomplished in Deluge. I think the first few years of my career in working with Zoho, I really was very proud of trying to find creative workarounds in the Deluge environment. And I think a lot of us probably do that. But I've really had a mental shift, I would say, in the past, especially maybe in the past month even, to say, like, I don't have to live my life as if Zoho Catalyst doesn't exist. And it's not very hard to just connect to Catalyst and to work on things in Catalyst if Deluge is either prohibitive or just very, very difficult. Like another example, I've been using the Java environment in CRM for years on and off when I want to use external libraries. And it's fine, it works fine, but it's a massive pain. It just is like, it's a really hard environment to work in. First of all, Java, if you're a Java developer, you know, like it's the most verbose of any of these languages we can work with on the platform today. You have to write 10 lines of code for everything. Second of all, the testability in that environment is really, really poor in the CRM Java environment. So now I just use Catalyst and everything is so much better. So as I say on the slide here, you have the ability to overcome execution limits, things like line, statement execution limits, things of that nature. You can use external libraries, but you're still in Zoho, which is, I think, the other big part of this, right? Is you could go to another cloud provider. Like I'm quite familiar with AWS. I could do a lot of this stuff on AWS. Then I'm outside of Zoho's data center, which is a very big deal to some clients, right? And we know that Zoho has this privacy-centric approach that other cloud providers don't necessarily have. And then also Catalyst is much more intimately tied to a lot of the Zoho applications that are consumer-facing, like CRM, in ways that a tool like AWS simply is not. So it does kind of give you the best of both worlds in that regard. Let's start by talking about things that are the same. If I'm a Zoho developer and I'm used to working in Deluge and I'm going to step into Catalyst for the first time, what is the same? Well, the good news is that as a Zoho developer, you already are approaching with a serverless mindset. Serverless, I'm sure it's a term that many, if not all of you, are familiar with, but just so I can say it for the record, it originated as a marketing term, but it has come to mean a very specific thing in software architecture. It's not that there are no servers. Of course, we know there are servers. They exist. But the server is of no concern to you, the developer, right? You don't have to do anything with that server. It's of no concern to you. Rather, you're given web services that allow you to accomplish the things that you're trying to do. And so if you think about that for a minute, something like writing Deluge in CRM or Creator or in Finance Suite or something like that, that is already serverless execution. You're already doing that. And so you'll be more comfortable coming into the Catalyst environment than someone who is much more used to like monolithic style software development, where you have one big software package that runs in perpetuity and has state management and things like that. That's good news. We'll talk more about event-driven architecture in a moment. Like I said, there's tons of things you can do in Catalyst. You can build like web applications. You can do all sorts of things. But for our purposes today, you can do a lot of the same things in Catalyst that you do in the Deluge environment today. So, and you can go back and watch my presentation on automation, because it deals a lot with this in the Deluge environment. Taking input, doing work, producing output. You do that in Catalyst just like you do it in Deluge. So the reason to go to Catalyst for something like that, rather than to do it in Deluge, is when the automation requirements are sufficiently complex that Deluge is not going to do a good job. And that's when you would consider going over and doing that work on the Catalyst side. And so same core principles, but more ability for complexity. There's a lot more potential and then a lot more complexity, potentially. Let's talk about the things that are better in Catalyst. I was going to say the things that are different, but I actually want to say the things that are better, because there are things that are just simply like, as a developer, if you like producing software and you've been working in Deluge, once you get your feet in Catalyst, you're going to be very happy in just like the things that you can do. So as I've mentioned already a couple times, you can scale without the same sorts of limits that the Deluge environment imposes. It's a pay-per-use model, and it's very, very cheap. So that's something like, if this is something you're paying for yourself, or if this is something you're working with a client with, it's definitely something you need to talk about, because the mindset for my experience anyway, the mindset for most people approaching Zoho is they're paying these licenses for CRM or Zoho One or whatever, and they're expecting to basically get everything for those licenses. Sometimes when you start to talk about cost for additional automation, that can be confusing. But I think, certainly my experience is that this is very, very cheap. Like, I have production Catalyst activities running that cost people well under $10 a month. For someone who's buying Zoho One, $10 a month on top of their licenses is basically nothing, right? And sometimes it's even less than that. There is a responsibility that comes with this, though, to design well, right? Because you can write some pretty bad Deluge, and as long as it executes, there's no impact on cost. That's not the case here, right? You do have to actually think for cost, and we'll talk more about that in a little bit. As I mentioned, you can accomplish things in a more complex fashion. We'll get into some examples of that. Observability just makes me smile, because I think we've all probably been in that situation on the CRM side or in some Deluge environment where we just don't know what's happening and we can't figure it out and we can't replicate it by execution. In Catalyst, because we can design with single responsibility functions, just the testability, the observability is just much, much better. You can use standard languages and import libraries, as we've discussed, right? I'll give you one like very simple example of this. We were beating our heads against the wall because we were basically trying to build Deluge that would find the next date, like given a recurrence rule, find the next date, right? And really the only way you can do this in Deluge is by iteration. You can really only say like, is this date good? Yes, no. Is this date good? Yes, no, and iterate. And so very quickly, like, it's not a difficult algorithm, but very quickly you hit statement execution limits if your date is a few years out. Now you can skip months or skip years and like get into that nuance, that complexity, but like all these cases you got to adjust for. What if it's the last weekday of a month that's a leap year? Like things like that. Very complicated. Lots of Deluge to write. Very buggy. We replaced that with a Catalyst function that just imported a Python library that handles our rule, and like we were done in 5 lines of code. You know what I mean? So sometimes things like that, it's like, it's not that you can't do it in Deluge, but you think about how much Deluge you're going to write, how much potential there is for a bug. The thing, time, we all know date time is very complex and it's not handled well in Deluge. It's just not. You leveraging something where you can bring in an external library. We've used machine learning libraries to some degree. We've used I'm trying to think what else. Before Creator had the QR code creation, I built a Catalyst service that simply created a QR code so that we had one that was free, that was in our environment that we could use, things like that. Another thing is you have available services. We're not going to really get into this today because it's just beyond what we can talk about in a single session, but there are lots of services in Catalyst, things like machine learning, tools to support chatbots. Web scraping is probably not the proper term, but like Selenium kind of automation testing, templating, and many more things. These services exist, they're built, and you can plug into them via web request and use them as a part of your application. And then finally, testability and version control. We'll talk more about testability in a minute. You have 2 environments in Catalyst, production and development, and unlike the CRM sandbox, they are true parallel environments, meaning that we build in deployment and then we push to production, and everything except for obviously the data itself and environment variables is built in deployment and pushed to production, which makes it just a lot more testable and a lot more controllable than what we have in any of the Deluge environments. Some things that are more challenging, the management of authentication. We all love the integration methods in Deluge. You don't have these in Catalyst. So you do have to do OAuth-based authentication and manage that. Now, there is a little tool, and if you look in the SDK documentation for your favorite language, you'll see for Zoho-based connections, you're able to use, this is the Python one, you're able to essentially build a connector here, and then this will manage it for you. This is for Zoho apps only, but this will manage it for you. So it'll cache your auth token in the Catalyst cache. And so then the next time your code hits this, if the value exists in the cache, it'll simply use it rather than refreshing. But if the value is expired or not present, it'll refresh and then cache it again. So that's it's almost like using a connection string in Deluge. It's mildly more complicated than that, but not too bad. For other APIs though, you're pretty much on your own. You have to build your own OAuth patterns. But once you build them, they're built. Obviously, with the potential for increased flexibility, there's also potential for things to go wrong. Cost must be managed, I'll put it that way. And then good design is just really important. We're going to talk a little bit about design here shortly. I wanted to share this quote for you. This is from a guy named John Gilbert. He wrote a book called Cloud Native Development Patterns and Best Practices. I think the title is actually even longer than that. It is a good book, and if you have an interest in serverless architecture, if you have an interest in cloud native design, it's a book I would pick up. But in the first chapter, he talks about this realization that he had, that he was thinking about building an application and needing his database, and then he was thinking about all the things he'd have to put in the database. And then he realized that in this cloud native style of development, the cloud itself is the database. And this is an introduction to what I want to talk about design-wise and acclimating yourself as a Zoho developer to the services that exist in Catalyst. The orchestration of independent services that communicate with one another by essentially messages, that is the application. That is what we're thinking about in this approach. We're not looking to the database itself in this case to understand what's happening in the application. We're rather building all of these services, any one of which could have information that represents the current state of the application. State management is very difficult in serverless, and we'll talk more about that too. But It's sort of a mindset shift. If you have been doing application development and you're used to like a 3-tier architecture, you can still sort of work that way. But my point is that we lean on the services that exist. And many of those services that exist are representational in terms of what's happening in the application. Where possible, we don't build things from scratch in this style of system architecture. We rather lean on the services that have been provided to us and simply extend them. Again, something that if you've been a Zoho developer should sound somewhat familiar to you, right? It's not different. It is different, but it's not that different. So in Catalyst, we work in an event-driven architecture. As I mentioned, our services are single-purpose components. John Gilbert calls them disposable components, right? Meaning that they work for the time they're supposed to work, and then we don't care about them anymore. They communicate through events or messages, and usually they conclude by generating a message that will trigger a subsequent service. This should sound somewhat familiar. These are scalable, and they independently run. They should handle failures gracefully. And then events can be logged for review and analysis. I promise I'm almost at the end of the very theoretical talk here. I just wanted to get us into what we can expect in Catalyst. Everything is event-driven. If you think about like in Zoho CRM, when you build a workflow, and so someone changes a field, and then because of that, some deluge fires, that is event-driven architecture. That's the exact same thing we're talking about here. The only difference is where in an environment like CRM, you typically have kind of one trigger and then one action. Here, because a deluge script can be very long and complicated, and here our best designs should be simple and single purpose, you can just have a lot more triggers and a lot more actions. And so that can get very difficult. Orchestration can be very difficult, but on a base level, it's very good because it's highly scalable. Everything is decoupled, individually testable, individually rerunnable. Okay, so let's get into how to really think about starting to work in this platform. If I've got some process that needs to run, and so I need to kick it off, there are lots of different ways for that to happen. Some of them I know I use more than others. Probably the number one I use is the API gateway. I'll show you that in just a moment. The API gateway, I no doubt you all have used APIs when you work with Deluge. The API gateway is you building an API that you can use. And that's how, if you're working in like a Zoho consumer-facing app and you want to integrate with Catalyst, a lot of times this is exactly how you do it. You call to your own API. And again, I'll show you that in a minute. API gateways have functions standing behind them that run, kind of like a webhook. I mean, it is a webhook essentially. It's the same thing, really. You also have cron and job scheduler. Cron is old, job scheduler is new. So you may or may not have job scheduler, but you can get it enabled. Job scheduler is just more sophisticated and much like I would use that going forward. It's much more robust than cron. But this is the job scheduler, as it says. You can create basically some function that runs on some schedule. The nice thing about job scheduler that's different from cron is that from code, you can actually schedule a job. So you can, according to some logic in your code, you can add a job to the queue. That's a really nice feature for managing concurrency. If something needs to run one at a time, and you need to make sure that it runs one at a time, using a job scheduler would be a way to do that. Signals is really awesome, and I think there's a Catalyst team did a webinar a couple months ago that I would maybe try to find and watch. So you can raise a signal, and in an asynchronous fashion, it can take data, transform that data, send it to an external API, get what is returned, transform the return data, and return it. It's essentially no code. It's like a template mapping kind of a tool. Really awesome. But you can also trigger things with that. Event listeners, this is also a really critical one for if you're working in an app like CRM. You have the ability to essentially listen to like a record edit in Zoho CRM. And so you can kick off Catalyst automation from a CRM record edit without even setting a workflow in CRM. Like that's one way to do it. You can set a workflow and fire a webhook to API gateway, but you can also just listen on the Catalyst side and have it run. Really cool. I'll show you a little bit about what that looks like. You can also invoke function URLs directly, but don't use these. That's my opinion. Others may say differently. I'll show you why. It's not that they're like so bad. I always use an API gateway, and I'll show you why in a minute. One more slide, and then we'll dive in. So for the execution of code itself, you have functions. This is extremely analogous to like a deluge function. It's code that executes. Circuits, which is an orchestration of functions. I'll show you what that looks like. And then AppSale is something very, very different that we're not going to really get into today. AppSale is a different methodology. It allows you to upload a software package using something like Flask, Node.js, or Java Servlet, and it actually is kind of a self-contained web backend or even front end if you're delivering HTML over the API that you build. AppSale would be really useful if you just have to have something long running. If you can't have these short running ephemeral functions, if you have to have something that is persistent, AppSale is really good for that. Otherwise, I wouldn't use it. I think the other solution is more cost effective and more scalable. But so AppSale would be another topic for another time, probably. All right, let me bring up Catalyst. I'll just kind of orient you here. Hopefully I haven't left you in the dust with all this. There's a lot. I know there's a lot. I just want to make sure I give you kind of an overview of what's here that can start to compare to what you may be used to in Deluge. So let's actually start by looking at these functions. And I loaded three very simple functions in here. They're all written in Python. Python is the language that I use. I think Node would also be a good choice. I'm personally not as proficient in Node, so I tend to use Python more. What's nice about Node is you can actually edit the code in the console. So that's a nice advantage. The others, you have to push them up. Java is there, and I suppose for the right use case, Java would be good. I used to use Java before Python support was added because I'm a proficient Java developer, but Java just takes forever to write, honestly. Like I would probably, if I was starting today, I would go with Node or Python for this. I think it's probably a better bet, just in terms of your own efficiency. So three relatively simple functions that will illustrate what they do here in a moment. We have our circuits, which is orchestration. We'll dive into that momentarily. I have one example for you there. You'll also see in the console, and again, we won't dive into these today, but the signals, the job scheduler, you can find all these over here. Let's look at the API gateway. So I find that in Cloud Scale. And I'm going to enable it. When I enable the API gateway, it's going to ask me if it wants to auto create or create a custom. I've actually never used auto create, so I can't really speak to how it works, but you could try it and let me know. I always create custom because I pretty much know what I want. I go next, and then it presents me this dialog to, I can say, create basically my method. And I can set the verb here, so if it should be a get, a post, or a put. If you're not familiar with what these signify, that's something to look into. We're not gonna cover that today. Although I'm happy to answer that question in Click or whatever. This is the URL it gives me. I set my component, which can be a basic or an advanced function or web client hosting, which we're also not going to talk about today. And then I set my function. You can set authentication, which is really nice. If you use the OAuth-based authentication and you're working with Deluge, you can actually make the connection string in Deluge work with this, which is really cool. That's a good way to do it. You can also use an API key, that's fine. You have request, like rate limiting, IP-based throttling, things like that. I always use an API gateway. And the reason why I do, the number one reason why I always use an API gateway is because the second you turn your API gateway on, then your functions are no longer publicly accessible directly. Like for that reason alone, I always turn it on. You can configure security rules for these functions. You can. Oh yeah, see, that's good. Let me disable this. So you can configure these security rules. It's not as good. It's not as robust, and like it requires you to come in here and deactivate things, which I don't love. I would rather just turn the API gateway on, know that I have good URLs in front of the functions that I want to be public, and then the rest is not accessible publicly. I would rather work that way. So for that reason, I never use directly invocable functions. Others may have different opinions, and I would love to know, like, if someone, if someone else is approaching this differently. But that's, for me, that's how I do it. That's how I've always done it. That's what I believe is the right way to do it. But looking at these functions, I turned API gateway off, so I can actually invoke these directly. I just put that in my browser because it's going to accept a GET, and there's my output. The code for this is pretty simple. This is in Python. With basic functions and with all function types except for advanced, you have this basic IO function. It looks different in each language. Basically, this basic IO object, and you can write with it, and that's what you saw come out of this. You can also get arguments from the query string or from the body, and you can, of course, do things. This is like about as simple as it gets. No, so they all look this way except for advanced. Advanced is different in that you actually get access to the HTTP request and the HTTP response. So advanced is the right one to use if you need to control the response in an HTTP sort of way, like setting the status code or sending a message, like things like that. Is when you that's when you use advanced. That's the only time you really need to use it advanced. And you see that this uses in Python uses Flask. Node.js obviously is meant for this, and that's what it's used for. But a lot of times I'll use advanced for the function invoked by my API gateway directly. If I need to, like, if I want to say, like, throw a 500 error, or throw a 404 error, or not 404, but throw a 400 error or something like that. Or to do redirects, right? Like a lot of times you might redirect, for example, one that I've done many times, hit the advanced function, do some operation that produces a file, get a public link for that file, and then do like a 301 redirect. I think it's 301. Geez, I'm not up on my HTTP status codes, I guess. A 301 redirect to that file, right? So from the user's side, they basically hit a download URL, but what they really hit was your function that produced the file and then returned it, right? So things like that, you need an advanced function for. But by and large, the basic functions will get the job done for almost everything. The other piece I really want to show you here are circuits. And I have a very simple circuit. Does one thing so that we can really get a grasp on it. What this circuit does is waits 30 seconds and then returns. Very, very simple, right? But the ability to wait is not something we really have in Deluge. Yes, I know there are some workarounds to it. None of them are very good. None of them would I rely upon for system critical things. The ability to build in some sleeping is really, really good. And so what I can do is, I just show you this here. This is, again, very simple. We're getting the SDK, and then we launch this circuit. And I have the circuit ID in an environment variable. I'll show you what that looks like in a minute. But all this code does, this basic function, is invokes the circuit and then returns. But this is actually really key. for asynchronous output, because I'll show you. If I go to my functions, it keeps refreshing like this in kind of a weird way. Sorry, if I go to my functions and I grab this trigger circuit URL, I've got that wait 30 seconds, right? This returns right away. So if you're dealing with like request response, that returned right away. It was essentially instantaneous. If I now go into the circuit, you'll see that it's running right now, right? So I didn't wait for this to complete for the HTTP response to come back. And that's really, really key if you've got long running processes, right? It's essential because you can't wait. You're going to get a timeout. You see it completed. So this was a very common pattern. We use this pattern a lot. Simple basic function behind API gateway that invokes some longer running circuit. If you need to check status, you can do that. You can log the circuit ID to the cache and then build a function that when you hit it, it'll tell you like, is the circuit still executing? Because you can get that information, things like that. And then with like a callback when it's done. I think job scheduling now takes the place of this pattern, at least to some degree. But previously, this was the only way to invoke something asynchronously off of like an API gateway. And so this is a really good pattern to know. Really, like if you're trying to get your hands into Catalyst and you want to try to build something asynchronous, this is a great way to do it. The other thing I'll say about this approach, let's see. Notice that I have the wait here in a stage. I don't have the wait in the code, which I could do. This is better, and I'll tell you why actually right now. Let me go back to my slides. So let's say we're figuring out this this Catalyst thing. We're like, oh great, I can use languages that are able to sleep. I can do all sorts of things. Let me just go ahead and do that. Here I have an example of, let's say we've got some data and we format that data a certain way. We send it to an external API. And let's say this is one of these asynchronous APIs that we work with sometimes where we have to send the data, we have to pull for the status, and then return the data when it's ready, right? So like if I was just writing this on my computer, on my desktop, I would probably write something like this, just every 30 seconds, check. And that might work fine for that, but it is bad design for Catalyst for a couple of reasons. First of all, when you directly invoke a function in Catalyst, it has 30 seconds to live. It will time out after 30 seconds. That might seem extreme, but it's actually a good thing because you pay for time. Your time is essentially, or your payment for function execution is essentially time times memory allocated, which you can allocate memory in these functions too. We probably won't show that today, but you can set different memory allocations. And so you don't want this thing to run for forever. I mean, that would not be good. You would be paying for nothing. So we need to design something like this in such a way that leans into the architecture we have. And that's what I talk about when I say the cloud is the database, or like the cloud is the whole system is built up of these orchestrated services. How I would build this is it with 3 single purpose functions. And so we have a function, this would be called off of the API gateway, that would, let's say, format the data, send that data to the external API, and then kick off a circuit, or maybe the job scheduler is the appropriate tool now, it would just depend. But it would kick off a circuit to say, here's the request I want you to pull for. Then in that circuit, we would have some sort of set of structures. I'll show you again the circuit builder in a moment. They would fire the check status function. And then based on the response to that check status function, maybe it would wait 30 seconds using one of those wait structures I showed you, and then go again. Maybe it would do that, I don't know, 10 times and then fail or something like that. You would build that, all of that structure you build not in the code, but in the circuit. Again, lean into the services that are given to you. Don't write code for something that you have a service for. It's one thing if you need to wait like 2 seconds or something like that, like sure, I'll write that line of code. That's fine. I mean, you're not going to add a bunch of features here just to wait 2 seconds. But for something like this, it's like repetitive polling. You definitely want to use a structure that you have rather than writing code. You want these functions to be as short-lived as possible. Again, think the word disposable, like John Gilbert would say. These are disposable. You want them to be quick and then gone. But then let's say it is ready, we return ready, and then we have another function that actually gets that data and does whatever it needs to do. I want to go back to the circuit builder here again for a second. And you can see, I should mention too, that you can also build these with, there's a markup you can also use if you like. Either is fine. But you'll notice you have these different structures. You have a branching structure. So you can say like, and you can pass input and output in these. So you can say like, if it's this, do it this, but if it's that, do that. And you can have different functions, right? You can process things in parallel, in batch. Imagine, for example, you needed to write, I don't know, 50 records to Zoho Books. Zoho Books doesn't have a bulk API. So if you're doing that in Deluge, you're doing it one at a time, and it might take too long. If you are doing it with a circuit here, you can do it 5 at a time. You can set that in the batch configuration. Let me just quickly. Yeah. You set your path, which shows like where the collection of variables is, and then you can say like how many at a time. I want to do 5 of these at once, right? So you can manage rate limits and things like that way. You can handle failures. There's retries built into this. And so if you think this is like one of the key differences between writing in Deluge and writing in Catalyst in a cloud native way, is that where in Deluge you might have a 2,000 line function that does all these things and has these branches of code and all that stuff. All of that complexity should be in your circuit, not in your code. And then what should be in your code should be single purpose functions that do essentially one thing. There is a little bit of an art to this. I mean, I would say there's like a certain level of like a triviality where you don't want to build out a bunch of infrastructure here if it's what you're doing is relatively simple. And like, I get that. And I'm not saying I've never written a function that does 3 things. Like, of course I have. But in general, from like a first principles kind of a perspective, we want the complexity of the orchestration to be in the circuit or in these other services like the job scheduler, where it is visible and not and honestly changeable without rebuilding code. Whereas we want the code execution to be finite, single purpose, disposable, easily tested. That's a bit of a change in thought if you've been doing a lot of scripting in Deluge. But I think once you acclimate, you'll really like it. Okay. One more thing I really want to talk about. The benefit of serverless architecture is the scalability. One of the challenges is managing like persistent data and managing state, especially. I'll give you an example of state management. I was working on something that was working with the analytics API, and analytics has a rate limit. I think it's 60 requests per minute is the rate limit. If you call more than that, it just fails. And so it's a bit tricky to manage because the analytics API also doesn't give you back any kind of header that says like how many you have left, right? Like a lot of times, that's a really nice thing in an API. If they're giving you something in the headers that say like, hey, you have 20 left for this minute or whatever, that's like really easy then to manage it. But I had multiple concurrent functions calling analytics. Again, this is pre-job scheduler, so I didn't have any kind of no locking tools. The Catalyst cache doesn't have atomicity. You can't lock it. So we had to eventually develop an algorithm that sort of guessed where we were at rate limit wise, and did its best, and it works pretty well. But you have problems like that, but you do have tools to help with those, like the cache I mentioned. You can store small pieces of data for up to 2 hours. I think it might actually be longer than 2 hours now, but it's still short term. Cache is small data, short term storage is always what it's for. If you look at that, if we go to cloud scale, it's there. So you can build these different segments, kind of like a table basically, and then the key, here's my value, 2 hours. That will be here for 2 hours, and then it will just simply disappear. So it's a good way to store ephemeral data, like if you need, and it's very fast. It uses Redis, which if you're familiar with Redis, you know that's kind of one of the industry leaders in terms of a cache. You also have database options. There's a relational database. There's a NoSQL database now. The relational database, in my opinion, is not very good for applications. I imagine it will get better. I know it will get better, but for like complex queries and things like that, it doesn't work very well. But for storing application data, it's great. I use it all the time. I basically build a 2-column table, like a field value or field name and field value, and then I encrypt the field value. And so things like API keys and things like that, I can store in that 2-column table, and they can be accessed from all my different functions at any given moment, things like that. NoSQL is also super awesome. We can't talk about it today, but our team just built some proficiency in NoSQL, and I really, really love it now that I understand it. Like, it broke my brain for about 3 years, but I think I get it now, and I really like it. Another one you have is file storage. Another very common pattern I use is if I'm pulling JSON data from an API and I need to just like hold on to that for a minute because a different function needs it. A lot of times that JSON data is too big to pass between functions, so you have to store it somewhere. Cache is the best option for that, but if the data is too large for the cache, you can throw it into a file, reference that file ID in the cache, and then the next function can pick it up basically by using that file ID that's in the cache to get the data. So like, in some ways, it feels like going back in time to start using file-based storage instead of database type storage, but it's very normal in cloud design today. Like for example, AWS S3, the simple storage service, which Catalyst's new file storage is very similar to that, Stratus, is like one of AWS's top services, right? So like using file storage for application data is pretty common these days. You can also use environment variables, but keep in mind these are per function. This gets to be kind of annoying, I have to say. So like in this one, I have in the environment variables, you can see this circuit ID, and here's the development value. It's good for something like that. If you're only going to use it for one function and it's not a secret, that's when I use them. I don't like them for secrets because, first of all, if I have to go change an API key somewhere, I have to go change it everywhere, that's annoying. And then the other thing too is in your offline version here, you'll see I have the environment variable right here. So if I'm pushing this to something like GitHub or something like that, those secrets are going to go unless I ignore this file. But if I ignore this file, then it's not going to work on the other machine. So I never use these for secrets. I would love to see Catalyst develop a more robust secret management tool. That would be awesome. Maybe someday. I know they're always rolling out new stuff, so I'm hopeful. Seriously, I'm hopeful. But for now, I use encrypted in the database. That's how I handle it typically. So those are the structures that can help you with persistence and state to know what's happening in your application. Two other things to manage or to think about in terms of designing in Catalyst when you know that there's likely concurrency, things will be happening at the same time. Don't get me wrong, concurrency is a massive strength. Like the fact that you can run a bunch of stuff at the same time and it should all work, that's great. But it comes with challenges. One of the things is, where possible, try to design things in an idempotent way, meaning that if it does happen more than once, that's not a problem. So an example of that would be like, let's say I'm pulling data from CRM, and then I have, I don't know, maybe there's a delay in there, maybe there's something else that happens, and then like a minute later, I'm writing that data somewhere else. And let's say it's possible that in that time, the data has changed in the CRM, and this is going to happen again. And let's say also that I don't have strict control over what happens when, which is true in this environment. It's true. So if what I do is right before the data goes to its output destination, I pull the fresh data, the freshest data from the CRM, and then use that, that's a good idempotent strategy, right? Because if it fires 50 times, no matter how long it takes, it's always going to pull the fresh data. And so it's reliable, right? Like things like that to think about. Like when you approach these, you always want to think about what does happen if this fires 5 times? What does happen if things don't happen quite in the sequence that I expected? And trying to build in points along the way where the systems can self-heal is really critical. And then managing current concurrency using queuing structures like event listeners or job schedulers. If you need something to really run in sequence, you have to use a structure in Catalyst that supports sequential activity. Otherwise, it really is a free-for-all, and so you have to account for that. I promised you that I would show you the CRM event handlers, and I forgot to do that. So let me just bring that up real quick, and then with a little bit of time left, I'll be ready for any questions we have. So in Cloud Scale, if I go to event listeners, and this is a queuing structure, these run one at a time sequentially. So that's a good thing to know. You see the Catalyst component events. If I create a rule, I can latch onto things that happen in Catalyst. Like, for example, if someone puts something in the default segment of the cache, I can trigger a function or a circuit. So that's a lot of times the way that these messages get passed, right? As a function concludes by writing its output to the cache, and the fact that it wrote its output to the cache causes the next piece to fire. But the thing that I think is way cool here is if I create one and I latch onto Zoho events, then you can see CRM. And so I can then attach from here, I can attach to like module changes and have automation fire here on the Catalyst side without any activity in the CRM until you write back to it or whatever. I use this a lot. Anyway, I hope this was helpful and not too much.